In 1979 AB2, we have this function defined by f of x is equal to x times e to the negative 2x power, with a domain of x between 0 and 10 inclusive. In part A, we want to find all values of x for which the graph of f is increasing and all values of x for which the graph is decreasing. Both increasing and decreasing are functions of the first derivative, and so we find f prime of x. It's a product, so we'll use the product rule. 1 d2 gives us x times e to the negative 2x times the derivative of negative 2x, which is negative 2. 1 d2 plus 2, the second function, e to the negative 2x times the derivative of the first, which is just 1. We can factor out the e to the negative 2x, and that leaves us with 1 minus 2x, e to the negative 2x times 1 minus 2x. If we're looking for where that's 0, to find the critical values, we have no zeros for e to the negative 2x, and 1 minus 2x is 0 when x is 1/2. And I'll set up a sign chart. We'll test a value of 0.25. At 0.25, 1 minus 2x is positive, and e to the negative 2x is always positive, so positive, positive is positive. 1 will give me 1 minus 2, which is negative, and so positive times negative gives me negative. And so we can state that the f of x is increasing for x between 0 and 1/2, and f of x decreases when x is between 1/2 and 10. So that'll do it for part A. For part B, we're asked to give the x and y coordinates of all absolute, maximum, and minimum points on the graph of f. Well, we know that absolute max and min will occur at critical values or endpoints. And so for part B, all we have to do is test the original function at the endpoints and at our one critical value. So f of 0 is going to give 0 times 1, which is 0. F of 1/2, when x is 1/2, e to the negative 2 times 1/2 will be e to the negative 1, which is 1 over e. And 1/2 times 1 over e is 1 over 2e. And that's roughly equal to 1/6. For x equals 10, we're going to get 10 times e to the negative 20, which is 10 over e to the 20, and e to the 20 is going to be a very small number, but not 0. It's going to be approaching 0, but not at 0. But it'll be much smaller than 1/6. So 1/6 will be the absolute max, 0 will be the absolute min, and I just state for justification that by the extreme value theorem, absolute max and min occur at either critical values or endpoints, and that's good enough. So that'll do it for this problem.